If you're not a mathematician or a scientist, you might perceive mathematics as a collection of techniques and instruments that are used to solve some technical problems. But mathematics is much broader. In general, mathematics is about applying smart ideas to non-trivial problems. Here I want to discuss a problem that is very hard unless you think smart about it. Right, so consider we have an 8 by 8 grid and we are provided with an unlimited amount of 2 by 1 tiles, like these. The problem now is to cover our grid with these tiles. Now, it's easy to see that if the grid is indeed 8 by 8, then you can cover every column in a trivial way like that and repeat this covering for all columns. So this problem is quite easy. But suppose now that I change my grid slightly by removing this corner and this corner. Right? So here's a new grid. These two corners are now deleted and the problem remains the same. We have as many tiles as we want and we want to cover this grid. Now, what do I mean by covering? I do not allow intersections. I do not allow putting one tile over another, and also I would not allow any empty cells to be left in my covering. The covering has to be complete. It has to cover all cells in the grid. So the question is, can you do it or not? And one way to begin would be to take these tiles and try provide such a covering, or at least begin it, and then maybe imagine how it's going to look if you have more tiles. Of course, the number of ways in which you can begin your covering is very big, and if you do not succeed with one attempt, there is no guarantee that you will not guarantee with other ways of putting your tiles in the beginning. So we need a different approach. We need to be smarter about it. And here's what I propose. Let's look carefully at our grid. It is 8 by 8. What do these numbers remind you of? Of course, this reminds us of a chessboard. But how does chessboard differ from the grid that I have? Well, the chessboard is colored in alternating black and white. So why don't I color my grid as well? Suppose I make this corner black, then by the rules of coloring, these two cells need to be white, and these have to be black, and so on. Now, if I just try and deduce the colors of these corners, what do I get? Well, they will alternate along a given row and along a given column, so I get this sequence. So this corner is white, and if I do it above here, I also get a white. How is this useful? Well, if we actually had a chessboard, then you can notice that in every row there are exactly 4 black cells and 4 white cells. So their number is the same. And this will repeat for every row. So in a chessboard, we would have 32 white cells and 32 black cells, because there must be the same amount of each, but there are 64 in total, right? But now we go back to my grid where these two corners are removed. So in my grid, I have 30 white cells and 32 black cells. I did not lose any of the black cells. So let us try to play around with this new grid using our 2x1 tiles. Well, immediately you can notice that no matter how you put it on your grid, either vertically or horizontally, it will always cover one black cell and one white cell, right? If you want to be rigorous about it, you can prove it by contradiction. Suppose that there is a position in your grid such that if you put your tile on it and it covers two same colors, well, that means that in your grid you must have two adjacent cells of the same color, which is impossible by construction. If we write down our observation, we can write that every tile covers one white cell and one black cell. And by comparing these numbers, you can sort of see how we are done. We arrive at a conclusion that it's impossible to cover this altered grid with 1x2 tiles. Why? Because overall, the number of white cells is not the same as the number of black cells. But every tile, in some sense, takes out equal amounts of white and black cells. So if we assume that there exists such a covering, then by this rule, they will have to cover the same number of white cells and black cells, which is not the same in the grid. So it is impossible. The problem is solved.